differential calculus. Differential calculus. I have a question here that I want to do with you, which I believe that by the time you take care of it, you will have established you in the aspect of differential calculus to the extent that you can say that we have done enough. After this question, we will move on. Cos kx plus b sin kx. You don't say we so. I have given this question before, and quite a number of you in this class struggled a bit with it, so that plus k square y is equal to 0. This is what they are giving us, and they want us to prove that this is equal to this. If our what is this one? This is a differential equation of second degree. Is that also? Yes, sir. And they want us to differentiate. What that means that they want us to differentiate this twice. I don't think that is a big deal. No, so what went wrong? So the first thing we have to do is to look at what the expression they have given us. So let us go. What? Equals to what? Cos kx plus sin kx. So let us now see divided. If this is y, we can say our a cos kx is equal to u left. And what?
B sin kx is equal to b.
Is equal to v. So we can therefore say y is equal to what?
U plus v.
U plus v. Is that also?
Yes, sir.
So what will now happen to our divide here? I need. So what we have now is this. We have y is equal to u plus v. Is that also? So the first thing we have to look at here is to differentiate this one. Differentiate this one to have this particular one. Are you getting what we are trying to say? So what will now be? It now become y, the y, the x is equal to what?
The u dy
The u dy
plus the v dy
plus what?
v dy.
The dy. That's so. Do you agree? Who is disagreeing? That's where some of you model this stuff. You need to know the difference between the two. However, let me quickly let you know that there is no need for you to actually go down and begin to belabor yourself with what you actually need to represent this one way. I just wanted to test your knowledge of product and quotient rule. If you have said, now, if this is y, the x here will be equal to what? D. The x bracket a cos plus what? Over so if this is what are you writing now? You are writing the u because this is your u and the v. So if you are now going to put that down, what will it be? The y, the x. It now becomes what? The u, the x
plus the v.
Any challenge about that? Are you going to see? What this one is telling us that you are differentiating this with respect to x. If you have a cos kx, you now say, you now give it what? D over the s bracket a cos kx. What means the what? Differentiation of a cos kx with what? With respect to x. So if you now come here and say the y, you are already differentiating with respect to y. And what you are going to get is 0 because y is not present in this expression. Are you getting what we are trying to do? You have to take note of that. So you have to understand when they are talking about product rule, when they are talking about quotient rule, you must be able to know what if I have, for example, if I say y is equal to pk, I now say the y dx, what will it give me? 0. Who can tell me why it is going to be 0? Okay. Because God bless you. The x if were to be here is because x is not here, we can put it as x raised to plus 0. So the absence of x here makes the differentiation go to 0. That's what we call differentiation of constant. Because x is not present there. So if you have put the y here, definitely you will have got a 0 because there is no presence of y here. And of course, your differentiation will have. That's the area I want you to understand. I believe with this now, all we just do is to do our differentiation with respect to this one. And of course, let us go if we have this, we want to differentiate this. Are you getting what I'm trying to say? The first thing you are going to remember is that what? This is product. A product rule where A is multiply cos kx. Is that not?
Yes, sir.
So they have to be treated as product rule. So what is du dx going to be? It's going to be equal to what? A d dx cos kx plus what? Cos kx dx a. Are you getting what we are trying to say?
Yes, sir.
Now let us quickly remind ourselves something. We want to differentiate cos kx. Let us now look at it. You have cos kx. It's like when you are having cos 2x. Is that also? If you want to differentiate cos 2x, what does it give us? Minus sin x. That is where we have some of the challenges. It means we are still struggling with this thing. If you want to differentiate this one, let us say it is actually y. It is t plus 2x. The first thing you have to know is that this one is b. So we can say, let 2x be equal to u. Then we have y is equal to cos u. Then we have the y, the u, is going to be equal to what? Minus sin u. Is that also? Then we also have the u, the x. What is it going to be equal? 2. Now, the y, the x, is going to give us what? The u, the x, multiplied by the y, the u. Because when you, are you going to say? So what is your the u, the x? 2. Multiplied by the y, the u. Sin u. So that gives us 2 minus 2 sin u. But where u is equal to what? 2x. So the y, the x, give us what? Minus 2 sin 2x. Now, let us now say we have cos kx. How will you now differentiate that? That's why you need to understand how the product rule works before you can actually take care of things like this. Because I realized it was at this particular point some of you messed up the thing. So for us to differentiate cos kx now, we can therefore say let cos kx be equal to our maybe our r, and we need the r, the l. Are you understanding? So the r this, let us say, let kx be equal to what? Maybe n. The n, the x is equal to what? K. Is that not so? And our r is equal to what? The r, the x is going to be equal to what? The n, the x times the r, the n. So we need to find the r, the n here. Are you getting what I'm trying to do? Because we are r is equal to what? Yeah. Where r is equal to cos ks, but x is equal to what? Cos m. Are you going to see? Cos what? M. So the r, the m is going to what? Minus sine m. Are you getting what we are trying to say? So the r, the m is now going to be equal to, the r, the x is going to be equal to the n, the x, which is what? K times minus sine n. Are you going to see? So, what does that give us? You can see that where those mistakes were made. Are you going to see? So it means the r, the m, the x is now equal to what? Minus k sine m. Where m is equal to what? Kx. So the r, the x is now equal to minus sine kx minus k sine kx. That is our differentiation of u. Are you getting what we are trying? That is our differentiation of what? Of cos kx. Now, are you getting what we are trying to say? So we can now rewrite this one, u, the x. Because this is where we are going to hand it, then you will do the remaining differentiation. Then we'll come back to it. It's now equal to what? A. Dot. What we have? Minus k sine kx plus cos kx dot dx. Why? Because it's constant, it doesn't carry this. I hope we can now see what is happening. So the u dx is equal to what? Minus k sine kx. Now we can now come here to differentiate our. We have, if we have this now, if you now say our v is now equal to what? B sine what? Kx. What will we define using this theory now? The v dx. What will it be?
Minus bk sine kx.
It's not the minor, because when you differentiate, it's going to be what?
bk cos kx.
Cos kx. So the y dx
is equal to
therefore
minus ak
is equal to what? Minus ak
sine kx
plus
bk cos kx.
Cos kx. Then we now differentiate this one once again. That is what we are going to do for me. Then we will continue in our next encounter. If we are able to differentiate that for the second time, what we are now going to add is a simple substitution whereby we will make k the subject of the formula and place it here. You are going to see the equation revealing itself. So do that for me in your additional next class, and we will see. Differentiate it for the second time. Then let us see what we are going to ask. Now that you know how to go about it.
Thanks, sir. Thank you, sir. Thanks, sir.